Welcome to class, everybody. So our lesson today is section 6.3, which is about adding and subtracting rational expressions. So far in this unit, we've learned how to reduce rational expressions, which is kind of like reducing fractions, except you have polynomials instead of numbers. And then yesterday, we learned about how to multiply and divide rational expressions. And today we're learning how to add and subtract them. So as a reminder, what we did yesterday was basically the polynomial equivalent to multiplying and dividing fractions. So when you multiply and divide fractions, you involve both the top and the bottom of the fraction. So for example, if you were multiplying 2/3 by 3/5, you would multiply 2 times 3, which would give you 6, and 3 times 5, which would give you 15. And if you wanted to, you could reduce that fraction. And then when you divide, you can either do the reciprocal thing where you find the reciprocal of the second fraction and multiply them, or you can use the method I showed you guys last time where you do the zigzag multiplication pattern. So like you go 3 times 7 gives you a 21 on the top, and then 4 times 2 gives you an 8 on the bottom. So when you're multiplying and dividing, you multiply the tops and the bottoms. When you're adding and subtracting fractions, though, you don't add the bottom parts of the fractions together. What you do instead is you find common denominators and then you combine them together. So the reason why you have to do this is because if you have 3/8, you could represent it with a picture like this, and 1/6 looks like this. And if you want to combine these together, you can't combine them until the pieces of the circle are the same size. Because like you could look at and say, oh, well, I have 3 pieces plus 1 piece. Well, that's 4 pieces, but these pieces are 8s and these are 6. And so you can't combine them together unless they're the same size. And so the way that we get them to be the same size is we find what's called the common denominator. So in this example, what would the common denominator be? 24, perfect. So to create the common denominator, what we do is we say, okay, well, 3/8, if I want to write it as 24ths, I think about, well, 8 times 3 will give me 24. And essentially what I'm doing when I do 8 times 3 is I'm making each one of these pieces into 3 smaller pieces. So I have a total of 24. So it's kind of like I'm like cutting them up into 3 little pieces like this. And this is the reason why I also have to multiply the top of the fraction by 3. So you know that rule where it says if you do one thing to the bottom, you have to do the same thing to the top? This is the reason why, because these 3 pieces are now 9 of the little pieces, because each of the pieces got split up into 3. So that means that we have 9 24ths for that. And then for the 6, to change that into 24ths, we say 6 times what equals 24? 4, perfect. So I'm going to multiply the top and the bottom by 4, which is essentially splitting each of these pieces into 4 little pieces. Whoops. So this is just kind of like a fast review of fractions from elementary school, because I know it's been a while since elementary school. So basically you make it so they both have the same denominator, because now all of these pieces are the same size as these pieces. And you can combine them together and say, well, if I have 9 24ths plus 4 24ths, that's going to give me a total of 13 24ths. So you find common denominators and then you add or subtract the top numbers once you get common denominators. And if you were subtracting, you would subtract the numbers instead of adding them. Do you guys have any questions on that? Or does that kind of make sense? Okay, so this is the way that we add and subtract fractions with numbers. So now we need to look at, well, how are we going to do this for polynomials? Because rational expressions are basically fractions that have polynomials instead of numbers. So how do we know that the common denominator is 24? Like, how do you find out what that number is?
This thing that multiplies into the lowest number.
Perfect, yeah, so these two numbers, if you were to list out all of like the times tables or the multiples for them, 24 is the smallest number that's in both of the times tables, right? Now, in polynomials, we don't have polynomial times tables. Thank goodness. Like, that would be awful if we did. So we need to know, how do we find the common denominator when we're working with polynomials? So let's look at these denominators in factored form, because we do know how to look at polynomial factors. And so looking at it in that way might be helpful. So the factors of 8 are 2 times 2 times 2. If you were to break them down into prime numbers, you would end up with 2 times 2 times 2. And then the prime number, or sorry, the denominator 6 could be written as 2 times 3. That would be the prime factorization of that. And then 24, I'm not sure, let's split that up. So 24 could be factored into 2 and 12, but 12 can be 3 times 4. 4 is 2 times 2. So it looks like the common denominator 24 has 3 2s and a 3. So when we look at the factored form of these denominators, what pattern do you guys notice between the two original denominators and the common denominator that we needed to find to be able to add the fractions together? What do you guys notice about those factorizations? Because like with polynomials, we'll be able to get like the polynomial equivalent of things that are multiplied together. And we need to know how we can find the common denominator from the factorized versions of the original denominators. So how could we get this black factorization if we knew what these two were? Do you see any patterns with those? Let's look at the first one. If we look at this, we have 3 2s in that denominator, right? And we also have 3 2s in our common denominator. If we look at this denominator, we have a 2 and a 3. Well, we have a 2 and a 3 in our common denominator as well. So our common denominator basically has to include enough factors to be able to build both of these denominators separately. So I kind of think about factors as like being the building blocks of a number, or like the building blocks of a polynomial. And your common denominator number, or we'll work with polynomials in just a second, basically has to have enough building blocks to be able to build each of the denominators separately. So like kind of like if you thought about these as being like Legos or something like that, you have to have a Lego set that's big enough to be able to build this and this. You don't have to build them both at the same time. Like we didn't have to have 4 2s. You could, it just wouldn't be the simplest common denominator. And so you only have to have enough to build each of them separately. Does that kind of make sense? Okay, so let's look at what this would look like if we're adding and subtracting polynomials together. So the first thing we want to look at is what are the factored versions of the denominators. You don't necessarily have to worry about factoring the top of the fractions, and I'll show you why in just a second. But we do want to factor the bottom. So for the first fraction, we have 5x over, and that first polynomial can be factored. We can factor out a 4 because they both have a 4 in common, and we'll be left with x plus 2. For the second fraction, we have x minus 6 on top. And this fraction, or this polynomial on the bottom, is a trinomial. So we can use our trinomial trick and say if we have negative 10x squared, because I take negative 10 multiplied by x squared, what are 2 things that multiply to negative 10x squared and add to negative 3x? Yep, minus 5x and positive 2x. So I'll split that negative 3x into those 2 terms and then do factoring by grouping. So the first group has an x in common, which leaves me with x minus 5. The second group has a 2 in common, which also leaves me with x minus 5. When I factor out the common x minus 5, I end up with x plus 2. So that second polynomial can be factored as x minus 5 times x plus 2. Everybody good with that? Okay, now I can't add or subtract these fractions together until I have common denominators. So I need to figure out what is my common denominator. So I'm going to draw out some new fractions here. I'm going to try to find out what this common denominator needs to be. Well, as we saw back here, like the 8 had 3 2s, and so our common denominator also needed to have 3 2s. So when we look at this one, our first fraction has a 4 and an x plus 2 factor. So our common denominator is going to need to have a 4 and an x plus 2 factor as well. Then when we look at our second fraction, this denominator has an x minus 5 and an x plus 2. Well, we already have an x plus 2 in our common denominator, so we don't have to list it again, but we do have to have an x minus 5. So my common denominator for these fractions is going to be 4 times x plus 2 times x minus 5. Do you guys have any questions on how I figured out what the common denominator was? Okay, now that I know what the common denominator is, I need to know how to get from this fraction to this one, where I have that common denominator. So if we go back to our fraction example, notice that like for this fraction, the thing that I needed to multiply 8 by to get to 24 was a 3. Well, the 3 is the only part of our common denominator factorization that's missing. Same thing with this one, we multiplied by 4 because the stuff that's missing from the denominator of 6 is the 2 times 2. So we're going to come back over here and we're going to say, okay, well, in this first fraction, we have a 4, we have an x plus 2, but we're missing the x minus 5. So I'm going to multiply the top and the bottom of this fraction by x minus 5. Does that make sense how you get that common denominator that way? And you got to make sure you do the top and the bottom, just like with regular fractions, how you have to multiply the top and the bottom because you're changing the sizes of your slices. Okay, so what that means is in our first fraction, when I do 5x times x minus 5, I'm going to get 5x squared minus 25x. And that's just from distributing the 5x to this. And you do want to put it in expanded form because in just a second, we're going to be adding or subtracting these together. And so you want to make sure you have it in expanded form. Now for this fraction, we look at what we're given. So we have an x minus 5 and we have an x plus 2, but we're missing the 4. So I'm going to multiply the top and the bottom of this by 4. And since we're minusing 4, I would actually think about this as being plus negative 4. Like that's kind of the way I would think about it because I think it's a little easier to deal with negatives if you put them there. So I'm going to do that same thing here. I'm going to write this as plus negative 4 times x gives me negative 4x. Negative 4 times negative 6 gives me positive 24. Is everybody good with what I did with that minus sign? Okay, and you don't have to do it that way, but if you do it a different way, you just have to make sure that you subtract everything. Don't just subtract the first thing. So now that I have those two fractions, and these two fractions have common denominators, now I can just combine them together. And I can say, okay, well, 5x squared, there are no x squareds in here, so that will just add up to be 5x squared. And then negative 25x plus negative 4x will be negative 29x. And the 24 doesn't combine with anything, so that would just be 24. And this is all over 4 times x plus 2 times x minus 5. And so this would be my answer. However, sometimes when you factor this, it will cancel out something here. So we always want to check and see if there's any way we could factor this because it might cancel out some of these factors and we may need to reduce it. So for this one, if we factor that trinomial that we ended up with, 24 times 5 is 90. No, it's not 90. 120, I think. So we get 120 x squared. Is there anything that multiplies to 120 and adds to negative 29? maybe 8. What's 120 divided by 8? It's what? 15? And 8 plus 15 is not 29. What about 6? 120 divided by 6. It's 6 and what? 6 and 20. But those don't add up to. Say it again. Negative 24. Oh, that's convenient that it was the ones that we had before. Okay, sweet, awesome. So we'll have 5x squared minus 24x minus 5x plus 24. Split those into 2 groups. The first group has an x in common. We end up with 5x minus 24. The second one we could say has a -1 in common. That leaves us 5x minus 24. And so it looks like this factors to be 5x minus 24 times, sorry, this is really tiny, x minus 1 all over 4 times x plus 2 x minus 5. So in this case, it can't, like you can't reduce it at all, so you actually can't simplify it. But sometimes like you might get like an x plus 2 and then it could cancel out the x plus 2s. So you always want to factor it just to check and see if it does cancel anything out. In this case, it didn't, but sometimes it will. All right. Any questions on this? Okay, let's do a check-in. Scale of 1 to 5. How are you guys feeling about adding and subtracting rational expressions? Okay, I'll go through a few more or one more example. But kind of the overall strategy here is you get the denominators into factored form. So that's what we did here. And then you use those factors to determine what the common denominators need to be. Yeah.
For the homework, do we have to factor it all the way to like the one on the right, or can we
To
do
this
like
one?
the second one? Yeah.
So you want to do this because on most of your homework problems, you will be able to cancel something out. That's the only reason you want to. If you end up with something like this, you could type this into your homework and it would still mark it correct. But if it worked out where you could have canceled something out, it won't mark it correct because it's not fully reduced. So you always want to factor it just to check and see if you can reduce it. But when it comes to typing in the answer, you can type it in either form. Yeah. Okay, so yeah, so you find common denominators by looking at the factors of your denominators that you're given, and then you multiply by whatever's missing. So like what I did here in red and blue, you multiply those, and then once you have common denominators, then you combine everything all together. Then you get your answer and you have to check and see if your answer can be reduced. In this case, it couldn't, but sometimes it will be able to be reduced. So that's kind of the overall. Most of the questions on your homework are not this hard. This is the hardest version of your homework. Some of the questions on your homework are super easy. Like on this one, you already have common denominators, so you don't have to factor anything. You just add them together. And in this case, you would actually end up with 8 plus x over x plus 8. But those two things are the same thing. And so if you do anything divided by itself, that's just going to cancel out and equal 1. So some of the questions on your homework will be really easy like that. And there's quite a few of them actually where you have common denominators already given to you. So it's really just the last few questions on your homework where you'll be given things like this or like this, where you need to factor them. All right, let's go through one more example and then I'll let you guys start working on your homework. So on this one, what would our first step be? Yep. Great job. We want to factor it. So the first polynomial on the bottom, and you don't have to worry about factoring the tops. In this case, you couldn't factor them anyway, but you don't have to factor the top, just the bottom. So if we factor the first denominator, what do both those terms have in common? Yep, have a 3x in common, which leaves us with x plus 4. And then for the second denominator, that one's already fully factored because you can't factor 2x any further. So we'd look at that and we'd say, okay, well, now that our denominators are in factored form, I need to figure out what my common denominator needs to be. So my common denominator has to include all of the factors of the other two denominators. So to take care of the first one, I know that my common denominator has to have a 3, it has to have an x, and it has to have an x plus 4. Then for the second one, my common denominator has to have a 2, and I don't have a 2 yet. So I need to put a 2 in there. And then it needs to have an x, but I already have an x as one of my factors. So I don't need to list that again. Now, this is not really the easiest way to list this because like you're like, oh, 3 times x plus 4 plus 2. But usually we put all of our coefficients at the beginning. So I'm just going to combine this 2 and this 3 and multiply them together to make 6. Because we know what 2 times 3 is. Everybody good with that? Okay, so this is our common denominator. So I'm going to write that out for both of the fractions. And now I need to look at what's missing. So I look at this denominator and I say, okay, well, I have an x plus 4, I have an x, and then I have part of the 6, but not the whole thing because I only have a 3. So what would I need to multiply this by to make it so that it's a 6x instead of a 3x? Yep, the factor that's missing is a 2. So I'm going to multiply the top and the bottom by a 2 because 2 times 3 will give me that 6. And so on the top of that fraction, I end up with a 4 because 2 times 2 is 4. Then on this one, I need to look at what's missing as well. So I say, okay, well, I have a 2, but I need a 6. So what do I need to multiply this fraction by? A 3, right? Because 3 times 2 will give me the 6. So I need to multiply the top and the bottom by 3. And then I also have to multiply by the x plus 4 because that's the other thing that's missing. Everybody good with that? Okay, so if I want to simplify this, I know that 8 times 3 is 24. And then if I do 24 times x plus 4, I'm going to get 24x plus 24 distributed to 4. Is that 96, I think? Because like 8 times 3 is 24. Then if I do 24 times x, that's 24x is 96. Okay, is everybody good with where that came from? Because I kind of did a bunch of steps in one in simplifying that. So I multiplied these two numbers together, which gave me 24. Then I distributed the 24 to these two terms. That gave me this. Now I add those together, and this gives me 24x plus 100 because 4 plus 96 will equal 100. This is all over 6x times x plus 4. Now 24x plus 100 can be factored because they both have, I think, a 4 in common. So I can write this as 4 times 6x plus 25. And that's over 6x times x plus 4. And this is an example where your final answer can be reduced because this is the answer to what happens when you add these two fractions together. But this can be reduced because 4 over 6 can be reduced to be 2/3 because they can both be divided by 2. So if I divide both of those numbers by 2, that reduces to 2/3. And my reduced final answer is 2 times 6x plus 25 over 3x times x plus 4. And that's fully simplified. And so that would be my final answer. And if you wanted to, I guess you could distribute the 2 or distribute the 3x. And if you typed in your answer that way, it would still mark it correct. But I would just leave it in factored form because it should mark it correct either way. So that's how you would add those fractions together. Do you guys have any questions on that? Okay. All right, then I'll let you guys start working on your homework. The first few questions are super easy, like questions 1 and 2 are just adding and subtracting regular fractions, like nothing to do with polynomials. And then you have a bunch of questions where you have common denominators or denominators that are pretty similar, so it's not hard to find them. And then the last few questions, the factoring gets a little bit more involved. So if you want to, you may want to work backwards on your homework, like start on the last questions and work backwards, because those will tend to be the harder ones. But what we did in class and what we practiced is all about the harder ones. So the easy ones should be pretty simple because they just don't involve factoring. So if you have any questions, let me know. And you guys can get started on your homework.